Hello. In this video, we're going to talk about how we can work with GitHub in order to effectively use it to track to store our track changes to our Git repository, namely how we can upload and download things from GitHub. So as you may recall, GitHub is a service that stores these Git managed projects online. Think of it like YouTube for Git controlled code files. We can use Git to upload and download from GitHub, but GitHub is just a place that stores things. So we've looked at having Git repos that get stored on GitHub and kind of what that looks like. So if you go to GitHub's webpage, you can be able to again look at sort of a visualization, right? A sort of just demonstration of what that code is that's currently stored in the repository on GitHub. So I'm going to show you from this example because it's a complex enough example, we can sort of show you the various pieces that are going along with it. So as I said, you'll start with things to notice at the top is that GitHub will tell you what organization or what user account this repo belongs to. So this belongs to the DPLA user, and then the name of the repo is Black Women Suffrage. There's a tab for the code, which is generally what we're looking at. So it'll list out all the different files from this project, from this application, from the under version control. These are different folders. You can actually click into these if you want to see them. So like we can click on the style sheets folder and then it'll show me all the files that are inside the style sheets folder. It opens up a sidebar navigation as well. So we can be able to do things like expand our way and go through different kinds of pages along the way. You can even view the files directly on GitHub itself. So if I want to look at this donate.scss file, which is a Sass file related to CSS, I can open it up and it'll actually let me see what the code looks like, and I can scroll through it with line numbers and coding and everything. It tells me a bunch of stuff as well as where these things came from, who changed it, and how these things work. So you can view code directly on GitHub in order to sort of see what it looks like. Now you can't modify it directly on GitHub. GitHub does support a way of letting you sort of make modifications and commits through their web interface. Don't do that. We don't do that. That's like really bad practice. We always want to be doing commits locally, make sure those are changes, and then pushing them, uploading them separately to GitHub. But we can go look at the code along here. You can go click on if you click on the name of the repo at the top, you can get back to sort of your home page. Other things to note, next to each file or folder, it will list out which commit last changed that file or folder, and then when that commit last happened. So you'll notice that this, this pages folder was last modified by a commit called parameterize the API endpoint. That's the descriptive message, right? Remember we talked about our short messages for commits, and that commit was last made 5 months ago at the time of this writing, as compared to the lib folder, whose last change was about fixes to reflect the data provider being an object, and that happened 2 years ago. So we can look at all the different commits and sort of see when each thing was changed. We can also click on this right here. We can click on this list of all commits. So this is our 320 commits made to this repository. If we click on that, it will give us a list of all the commits that were ever made and when they're made them in reverse chronological order. So this is where it lets us see what happened on April 22nd. Here's a series of commits that were made. Here's some other commits that happened along the way. This is part of why it's really important to have good documentation, right? Good messages and explanations for your commits, so that when someone's looking through the history and we want to know when things were changed, we understand what was going on each step, right? So we understand that this change here added Claire Collins Harvey. It's not just that there was a change and we don't know what's happening. You don't have to go look into the code itself to see what change was made. It'll actually let us understand what was going on here. The numbers here are being used for like data tracking, for understanding for sort of their task management structures. But again, this is like explaining what these messages are. Notice these aren't overly complex, right? This one swapped the order for collections. It doesn't explain how or why or what exactly that is. It's really just saying like, oh, if I want to talk about like when did the order change? Oh, the order changed back here on February 10, 2021. So we can go through that commit message. Note, it'll also tell you which user made these commits. This is mostly maintained by one person, it looks like. One person, or two people. There's a couple people doing all these commits. This is, again, why you set up that user account, and you sort of want to set up who and configure Git so it knows who you are, so that when you're making these commits, it's able to track who did what. So we know who made a change. Okay, those are the main things to keep an eye for. So again, you can look to see when each file or folder was last modified and which commit it was modified with, and then you can go look at this history of all the different commits along the way. Okay, this is a fairly like robust, complex repo. It's had a lot of different people working on it. It's been working around for a long time. More likely, the repos you'll probably encounter in this class to start are going to. Oops, sorry, that link is wrong. Let's do Ross. Are going to look more like our sample repo, right? This is what we started with and we were demonstrating in the previous video, where there is exactly one commit, the initial commit. And that was 2 days ago when I sort of was setting this up. And it was just telling us that we had these files and that's just our initial commit, right? Not a lot of here happened. And that's okay, right? It doesn't necessarily have to have a huge amount of history here, but this is going to let us know what's going on. Okay, so that's what a repo looks like on GitHub. That's about the things we're going to need to be able to work with. A couple other things I want to note about using GitHub that are going to be potentially relevant for sort of like getting started here. You'll notice that all these repos have up here at the top a button called fork. The fork button will let you take a copy of a repository that's on GitHub and make a new copy under a different user's account. So currently this Git demo folder is under the Joel W. Ross account. It's under my account, which means that I have access to it. I'm allowed to modify it, but no one else is. If somebody else wanted to be able to modify this, a copy of this code, they would need to hit the fork button in order to copy that over into their account so that they have access to it and are able to use it. I'm mentioning this now because if you want to follow along with practicing with GitHub from this video, you'll need to take this repository and fork it, make a copy of it so that you can actually upload and download things because you won't have access to uploading and downloading to my account because it's my account. You can't touch it. So you need to fork it to make a copy. So again, all that forking does, it says, let's take a repository under one user's account and let's make a copy of it at like a sort of a snapshot copy of it with all the commits, all the history, everything along with it. Make a copy of that repository under a different account. That's going to be useful for like this demo. For this course, you're not going to be forking things very often. We actually aren't forking repositories very commonly. In this course, instead, rather than having you fork different like repos in order to work with, we instead use a tool called GitHub Classroom that lets us create forks for you, sort of private forks that are under the Classroom's account, but that you have access to. So they're not under your account, they're under the Classroom account, but you're able to act as if they're under your account. So if in order to work with this class, you'll be given links in order to access repositories for assignments. You're going to go follow that link. It'll ask you to accept the assignment. You hit accept, and that'll then run the system. That'll then create a private copy, a private fork of the repository for you under the GitHub Classroom's account. Okay, don't otherwise hit fork, right? This creates forks for you. Don't also hit fork because you've already forked by accepting assignments and making everything come together. Okay, great. So that's sort of getting us started. So how to actually now interact with GitHub? Well, we've got our Git demo repository, right, that has no commits, that only has this initial commit. That's all a copy of code that's made. But as you may recall from our previous video, we've actually made, oh gosh, I did it again. Online. We've actually made a number of small, but we made a number of changes to our code that are on our local repository, on our local copy, right? So on my computer, on my laptop here, I have the database says, oh, here's a list of all these changes that were made. Here's a whole bunch of stuff that's happened, right? Here's 3 different commits, 3 different versions of the code that we've gone through, right? If I run git status, it tells me that's what's happening, but I have these 3 commits that are not on GitHub, right? GitHub doesn't know about them. That's because Git, not GitHub, but Git itself is a local process. It only works on your own local machine. You can do it offline. It doesn't require internet at all. It's just totally keeping track of the different files on this local database. Now, if we want to take these changes that we've made and we want to upload them to GitHub, I want to say I'd like my GitHub version of the repo to have that list of commits along with it, alongside my local copy. We're going to do that using another command, another Git command called push. Push is how we're going to take our local code and we're going to push it online. We're going to push it up into the cloud. We push to the cloud, right? We say take locally, where does it go? It's going out. We're pushing out. So we're going to use the command git push, and that will take all the commits that we have locally and it will upload all of them to GitHub. We push all the commits we've made. So we can push after every commit. We can make lots of commits and then push them all at once. It doesn't matter. We can then push to that commit, that remote, to that repository. All right. So that's all we need to do. So we're going to make sure that we are in our Git repository folder so we can run our command. And the command we'll run is going to be git push. And when I run git push, it's going to give me some details about the fact that it needs to go through a process, a bunch of data, it compresses it, and then uploads it, tells us what it's writing it, and then it uploaded those data to this repository. It tells me where I uploaded it to, and then it tells me it took me from this commit hash to my newest commit hash, right? Notice it went from the initial commit hash to the new commit hash on the main branch and everything set up. Great. So that uploads our code to GitHub. If I now go to GitHub here, I have to refresh this web page. But if I refresh the web page, now you'll notice that it says there are now 4 commits that the GitHub knows about. These files haven't been modified, right? They haven't been modified since the initial commit, but my index file was last updated 20 minutes ago when I recorded the last video about when it was undoing adding cats and dogs, and then this one was modified 10 minutes earlier when we added the animals. So we've now uploaded our commits to GitHub so that GitHub can now see these changes. If I want to make further changes, right? If I want to add in, oh my gosh, let's see. You can see this on GitHub. We're going to add in a paragraph to this. So I've added some code. I've modified my code. Remember, our local process here is because I modified my code. I have a modification I need to put into my staging area. I'm going to add to the staging area. I'm going to commit add GitHub message. I commit that. Remember my -m to make sure I'm committing it. And again, now I am up. Now I have I'm one commit ahead of my origin, right? There's one commit that's on my local computer that isn't on GitHub yet. So in order to do that, I'm going to do git push again. That uploads it back up to GitHub. I refresh the page again. Now there are 5 commits that was recently added just now, and everything's coming together. You can push whenever you want, right? I can just write git push, and if there's nothing to push, it'll tell me if there's nothing to push. Everything's up to date, and that's fine. So again, commits are happening locally. Push is just kind of uploading copies of them. Now you'll notice that even when I push things, like it wasn't that it got pushed now. Like I pushed it right now, but it's pushing the commits that were made in the past. So commits are really timestamped to when they were made. Push is just being used to say, let's put a copy of those commits on the internet for other people to be able to see, for other people to be able to access and look at and see how that works. Great. And that's how we can then push to these other repositories. Okay. You'll often potentially see the command git push origin main or git push origin master, potentially with a -u in there. So git push, if you just write git push, that by default will push to the current branch on the origin remote, on like the default remote, right? Because as I said, this GitHub, I cloned this repository the first time, it came with a link back to that remote. It came with sort of a bookmark that said, hey, where did I come from? To the origin. So when I do a git push, it says, well, if without any extra detail, it says, I'll just default to push into origin. And if you don't specify anything else, it'll push to main, to the main branch, because that's what we're on. If you want to specify that you want to push to a different origin or to a different remote, you can do that. You can say git push and put some other address, right? HTTPS, like some other repo. You can put in a different address, a different repository, and then you can push the main branch on some other repository. That's only going to work if the version like histories match up, and so it's very rare to do that, but it is possible to specify which origin you want to push to. Similarly, if I want to push to a different branch, and we'll talk about this more when we talk about branches, I can use that as the next argument. So I can say I want to push to the origin remote, but I want to push to a different branch along the way. So occasionally, once we get to branches, we'll start doing that kind of pushing to push to those different places. The -u argument here sets up what's called branch tracking. So it makes sure that, like, I'm saying for this first time, I'm saying I want to get pushed to origin and main. The -u sets those to be like the default, so that when I then just use git push in the future, it knows what the defaults are to be able to use. There's nothing wrong with always using the full term, right? There's no problem with using git push origin main every single time, but you can also just use git push to push. Either approach will get you where you need to go and work fine for this class. Okay, so that's what we've got. That's how we really work with GitHub, right? We talked about cloning. That's how we're going to download a repository initially. So we get a copy of that repository on our local machine. We make changes locally, right? We commit stuff changes. We then push them in order to upload those commits. Push won't upload the files necessarily. It uploads the commits, the changes, the new version of those files. So anything that hasn't been committed won't get uploaded to GitHub yet. There is similarly a git pull command that is used to download commits that are on GitHub, but not on our local machine yet. This is going to happen more once we start doing collaboration. And so there start being other people who upload commits, and then you need to download those commits as well. We'll go over that more once we start working with more with how to do kinds of collaboration and branching and sort of merging along those ways. But I want to just note again that as a command that exists, it's a thing you might use. Okay. So here's again the overall process that we're following. And this is particularly for assignments for this class because that's the context we're using. Generally, if you're going to work with some GitHub, you need to make a copy of that repository for you to be able to have access to. So for assignments here, you would follow a link from Canvas, accept the assignment, and that's going to create your own local copy. Similarly, if you were trying to work with some other open source repository, you might fork it in order to be able to work with it. Or if you have access to it, then you've already got your own copy and you're good to go. You can then use clone to get a local copy onto your machine. You then modify all the files from that, on your machine locally, test them, make sure they all work, add them to the staging area, commit them to get them back into your local repository. Once they're all there, you can then push them back up to the cloud, and so that now everything's up to date. And that's how we modify code that's tracked by Git and stored on GitHub. We never modify it on GitHub directly. We always download it, modify it, make sure everything's working fine locally, test it locally, and then once we're happy with that commit or whatever the sequences of commits are, we push those commits up to GitHub. It's fine to have lots of different commits. That's okay. Like again, you saw the DPL one had 320 commits, and that's a relatively small project. It's fine to have lots of commits here. Think about each commit saying, what's a version, what's a set of changes I want to snapshot and save and work with. Okay. The reason this gets used for GitHub then is because this lets us be able to do collaboration kinds of work. And I won't demo it through this video because it's just me, but this is the basic idea is that I could have my repository living on some centralized server on GitHub, and each different person who's working on this project, right? Each member of the team, each member of the group, everyone who's working on this repository together, each one of them clones that repository to have a local copy, to have their own version of that repository on their computer. Now, on their computer, they can make changes. They can work in the files, they can add to the staging area, they can commit them to the repo, or modify files, stage them, commit them, modify, add, commit, modify, add, commit. They can keep going through that cycle. Once they're done, once they've got a set of code they want to share with other people, they push it back out to that centralized repository, and then everyone else can then pull, which is we'll talk about the command in a moment, or in the next video, but they can pull down those changes and download those commits into their own copies of the repository. And this way, all of our users, all of our group members are able to keep their code synchronized to each other by effectively all sharing it through the centralized repository, which also keeps track of all the changes that are made, documents all the changes, and we can be able to see who is doing what, when, why, and how it all works. Okay, we'll go through, again, this collaborative process in more detail when we start talking about working with branches and merging and all the other pieces that go along with that. But that's the basic idea of working with GitHub. So again, the really important things to note, make sure you clone your repositories so you can work with them, make your commits, make your local changes, and then you push your commits in order to upload them back to GitHub so that other people in the world can go see them. Great, thank you.